Welcome. Hollow structural sections are increasingly favored as beam members in contemporary construction, necessitating reliable connections to transfer shear forces from HSS beams to HSS supports. In RAM Connection 2024, 2 new shear connections are now available to support joints with HSS beam sections. Let's take a look at how to assign these connections in RAM Connection standalone. As you can see, I've already created 2 joints in this model, a beam column flange joint and a beam girder joint. Both joints contain HSS beams and support members, and both joints will require a steel connection capable of resisting shear forces. Let's start with the beam column joint, which is already selected in the joint selection area. The design code, the AISC 360-22, and the load combinations have already been defined. We are now ready to assign the connection. In the ribbon toolbar, select the Design tab and then click on the Assign icon. In the Connection Assignment dialog, you're going to notice that 2 new shear connections have been added for HSS beam sections. The first is the double shear plate connection, where 2 plates will be located on either side of the beam, sandwiching the HSS member. The plates have holes aligned with each other and the HSS member, allowing bolts to pass through, thereby creating a secure and robust connection. The next connection is the unstiffened seated connection, and this is only available for a beam to column situation. In this connection, one HSS member will be seated onto the other, and welds will secure the connection, providing resistance against forces. This connection is particularly effective for applications where ease of assembly is important and additional bracing elements are not needed. Now, both these connections are available in a basic connection and a smart connection workflow. For this exercise, we are going to go with a basic connection workflow, and we will be selecting our double shear plate connection template. Once you've selected your connection template, click on the Assign button, and RAM Connection will assign the appropriate shear connection to the currently selected joint. After the shear connection is assigned, I like to take a look in the joint selection area. Here, I'll be able to see the status of the connection design and the controlling load combination. Here I can see the interaction ratio is less than 1.0, but it is in yellow, indicating that a warning was produced during the connection design process. That being said, I'm going to want to enter the connection pad for this joint and make some manual changes. To do that, I'm going to go to the Design tab in the ribbon toolbar, click on the Edit icon, and then I can edit my shear connection. This will allow me to customize the detailing for the currently selected connection. If I scroll on down, I can see all of the double shear plate parameters that I can customize. The first parameter I'm going to customize is my through bolt material. Now, looking at the top of the connection pad, I'm going to notice that my interaction ratio is in yellow, meaning that a warning was produced during this connection design process. To review those warnings or any errors that you've encountered, you can access the report through the connection pad by clicking on the results icon. Scrolling down in the steel connection results, I can see that the horizontal edge distance should be increased to be greater than or equal to the minimum recommended value. I'm going to go ahead and close out of the report. I'm going to find my horizontal edge distance, and let's go ahead and bump this up to 1.5 inches. Now I can see that my connection design has passed all code checks without producing any warnings, since it is now indicated in green. In addition to that, I'd be able to customize any of the plate materials or thicknesses, as well as the bolt layout and bolt material properties. Within the connection pad, I can also access the DXF drawing to see how this connection will be detailed. At this point, I did go ahead and make some changes to this connection. So let's go ahead and click Save, and then we're going to exit out of the connection pad. Now that we've assigned the double shear plate connection, let's try an unstiffened seated connection for a similar joint. So I'm going to copy this joint with all of its joint data. To do that, I can select the joint, go to the Home tab in the ribbon toolbar, and click on the Copy Current Joint icon. Here, I'm going to go ahead and say I want to reassign a new connection template. So I'm going to go to the Design tab in the ribbon toolbar and click on the Assign icon. Now this time, instead of the double shear plate, let's go with an unstiffened seated connection, specific for an HSS beam member, and click the Assign button. Now I can see that the appropriate connection template has been assigned, and it's passing all code checks since the interaction ratio is less than 1.0 and it is indicated in green. Again, I can access the connection pad to customize this connection as needed. The last thing we're going to do in this video is take a look at a beam girder joint. So here you can see I've already established a beam girder joint with an HSS beam section and an HSS girder section. Again, I need a shear connection for this particular joint. To start the connection assignment process, let's go to the Design tab in the ribbon toolbar and click on the Assign icon. Here we're going to notice that the beam girder option is selected, and we only have one option available to us here. This is our double shear plate connection. I'm going to select this connection template, click on the Assign button, and then click Close. In the joint selection area, I'm going to review the status of the connection design, and I can see that we passed all code checks without producing any errors or warnings. If I wanted to access the connection pad, I can click on the Edit icon and edit my shear connection again. At this point, this concludes our process for assigning a shear connection to a beam to support joint that has an HSS rectangular or square section as your beam section and a rectangular square section as your support section.